My name is Salisu Umar. This is a video for my Capstone project for the Advanced Data Science with IBM on Coursera. In this video, I will be discussing on the dataset and use case, architectural choices, data pre-processing and feature engineering, and then the model algorithm as well as what model performance indicator. Now on the use case, on the dataset and use case, as we can see, the dataset is in a CSV file, then it contains features using assessing heart disease. It contains 14 columns as follows. It contains age in years, and we have sex, we have chest pain, we have resting blood pressure, we have serum cholesterol, we have fasting blood sugar, and the rest. As you can see them, they are almost up to 14. But the most important one is the target here. The target tells us whether the person have the disease or not, which is 1 if he has the disease or 0 if he doesn't. As for the use case here, the dataset is using predicting whether the patient has heart disease or not. But as we can see, this is the representation of the dataset on the Excel. As you can see it. Wow. Then the solution to the use case. The solution here is just to predict whether the patient has heart disease or not. I use Apache Spark ML to create a logistic regression model and a multi-class classification evaluator to evaluate the model performance. The model worked well on the training and test dataset and was able to predict a diseased patient or not with an accuracy of about 55%. So the architectural choices here, my dataset was in the CVS format, and then the data repository, I use a IBM Cloud Object Store, which is like a file system storage. And then we have the discovery and exploration. I use Jupyter Notebook, Python, PySpark, Scikit-learn, and Pandas, and Matplotlib. As for the analytics and actionable insight, I use Apache Spark ML and Python. Wow, data quality assessment. The data has no much quality issues except the values are string instead of integer and floats. So the following exploration were conducted to assess the data quality. We have count. The total number of patients was counted based on the two types of values under the target column. So either they have the disease or not. And then the mean was also counted. The mean of the columns was taken based on the two types of values under the target column also. Then we have some visualizations like histograms and scatter plot were used to visualize the data. So here, as we can see, under the counts we have the count for each value or under target, that is either how many patients have the disease and how many don't. As we can see, 165 patients have the disease and 138 patients don't. Then there's also a count on the percentage. We have 45.54 of the patients who doesn't have the disease, and we have 54.46 of the patients having the disease. There is also a count on the percentage of males and females in the data set. As we can see, the percentage of female patients was around 32 and the percentage of male patients is around 68.32%. So then as for the quality assessment on the mean, here I calculated the mean of other features based on the two values of our target. So having disease or not, that is it. Then the mean of most of the features is not relatable, but that of age says a lot. The mean of the age of those with heart disease is 57 approximately, while that of those who doesn't have the disease is 52 years. Then under visualizations, some charts have been plotted. As we can see, as a bar chart visualizing the frequency of those having the disease and those who don't, both in males and females. 0 is for females while 1 is for males. But as we can see here, the frequency of heart disease in male is very much higher than that in females. Then we have the distribution by age. As for the blue bar, it shows those who doesn't have the disease, but the orange bar indicate those who have it. So around the age of 42, there's high rates of heart diseases, while there's high rate of heart diseases also around 64 years according to this data set. So we have also a scatter plot here, which is also a distribution by age. As we can see, the disease is almost distributed, is highly congested around 40 to 50 years, and very much sparse around 30 to 70 years old. Well, as for the data pre-processing, where I carried out the extract transform load, the data has no much quality issues except for the case of strings. So I perform an extract transform load where I split the data set into a training and test data set. I then convert the funders data frame I was using initially into a Spark session data frame by creating a schema. So during the creation of this schema, I have to change the column values or the column data types to be integer and floats respectively where they are needed, where necessary. So finally, the pandas training and test data frames were loaded into a Spark session training and test data frames. As we can see from this image, this is actually what happened first. There's a split using a scattered learn train test split, which split the pandas data frame into a test and training data frame. Then I created a schema. Then this is where I load. As we can see, df train and df test is where I loaded the pandas data frame into a Spark session data frame. So as for the future engineering, as for my level, I want my level to predict whether a person have the heart disease or not. Well, for the features, I use almost 13 of the columns: the age, sex, chest pain, etc. Here I created a label from the target column using a string indexer. The label will be used in predicting heart disease. I also created a feature column using a vector assembler from the above features. The feature columns was normalized using a normalizer, as we can see in the image below. So as for the model algorithm, here I use Apache Spark to create a logistic regression. A logistic regression, I named it LR as the variable. I also created a pipeline, and its stages include indexer, vector assembler, normalizer, and then the logistic regression variables which I created earlier. The model was created and passed to the training data set as a starter. Then the prediction variable was created and predict the performance of the model. So finally, for my model performance indicator, I use an evaluator, and I use a multi-class classification evaluator to evaluate the performance of my model. The metric evaluated was the accuracy. So thank you. I have been able to use Apache Spark ML to create a logistic regression model. I also use a multi-class classification evaluator to evaluate the model performance on both the training and test dataset. The model performed well on both the training and test dataset, hence the model is good and we have no overfitting. Thank you for listening.